Alrighty, welcome to stream recording that I'm going to make for Dr. Mark Randall and Computer Science 376 at the University of Evansville. This is a continuation and hopefully a satisfaction um, completion for my project number 5 for the CS376 class. I'm dealing with um, Network REversi, or commonly referred to as Othello. So Dr. Randall, I'm going to kind of walk you through what I've got here. I've written up a little bit of the documentation, but I figured it'd just be easier to record the interaction, and at least that way you can watch something. I'd have to read a somewhat lengthy report and I'm just trying to get it done and kind of experimenting with OBS and those kind of things. So bear with me. All right, so I've got the project pulled up, and this project was set up such that it was um, six different sub projects within the solution. So this is my Visual Studio window, and I kind of outline this in the in the documentation. But what I have is I have two applications. One is the server application, that's this REversi server. The other is REversi client, which is what the client will use. And I'll launch those and kind of show you the functionality of the game as we proceed through those. Admittedly, I did not meet all of the stated goals as outlined, but I'm hoping that the work I did on this is more than satisfactory to at least demonstrate proficiency of what's going on. There are 4 different libraries that are available. It's the client server library, a game objects library, a global settings library, and a general REversi game specific type library that's utilized by the client and the server. Both of these guys are using so many common functions and routines. I went ahead and performed all of this stuff. Now, information about the client server library, this is actually was being developed at the same time as I was working on my senior design project, and contains a lot of information regarding sending of packets back and forth across a TCP IP connection. Inside of this library is also a server manager. So I kind of developed that for the game as well. So it's actually got a load balancing feature. So as connections come in, it spins off up to 4 different threads, spins off a thread for a particular game manager or a chat manager that will now handle all of the connections for a particular game between players, so that the chat functionality and the game functionality would be utilized on their own thread, and it allows parallel processing and doesn't bog down. Now, again, we're talking, I think, 5 simultaneous games, 10 users, not a big deal, but this thing would be scalable foreseeably up to hundreds or thousands of players simultaneously. Not that that will ever happen. And so a lot of that functionality is contained within the client server library. And again, it's used by both the REversi client and the REversi server, which contains specific information and implementation of rule sets and checking and those kind of things. The game objects are your basic class models. This project was developed using MVVM pattern model, view model pattern. And so I've got different classes established for the board object, chat model objects, a bunch of enums related to kind of some, whether it's the players. Let's see. I open that. Here we go. You can see that, so I've defined, an undefined player, player 1, player 2, and the idea being that by default it sets up for 2, but if a particular game were ever added, some sort of multiplayer game or something, that I could overwrite this enum, and then the same server functionality would still work as it cycles through all the player enums. Okay, likewise for different shapes of pieces. This game originally had the functionality of drawing both circular pieces as well as rectangular shapes, and that does work, although in the live application I can't switch between them at this point, but the functionality is there. So there's our region shapes, which is the shape of the tiles. Ideally being that if I ever had a game that was hexagonal based, or some sort of circular region shape, that I could then be able to implement this, and all the server logic and the game board manipulations and the rules checking would all follow the same basic approach. I included direction vectors. This should probably be down in, this is more for rectangular. So if I have a cell, this identifies adjacent cells based off of these vectors, and it searches through all of these direction vectors. And again, foreseeably, if you had some other hex or circular shape, then I could overwrite this, and again, all the checking and the logic would all be in place to be able to work over that. And then, of course, game sounds, for a successful click, for tiles being flipped, so forth and so on, all of those would be present as well. And again, in this application, I don't have those currently turned on, but I figured I would just show you more of the functionality of what's going on. So that's the models of the game objects. The global settings, that basically contains the connection information, so the location of the server address. So this is being done on one computer, not across a network, but it identifies the address as 127.0.0.1. Okay, and then I have a port assigned for the game server, and then I have a port assigned for a chat server. You can see that those are two different number ones. And so these are where the connections are made, and then the server manager knows how to find the different games or the different chats that are taking place once those are implemented. Okay, the REversi contains the models and the view models for the REversi specific information, which is, how does the game board look, how do the game pieces look, the game view models and player view models, and those kind of things are all being set up here, as well as specific information related to the chat model on the client, as well as the game models being set up there. All of these REversi objects inherit from the game objects up above. So they have some base functionality defined in the game objects library, but then a game specific would inherit from these game objects and implement its own format and setup, right? So those are the dynamic libraries as they're currently set. The REversi client then is everything that the client sees in the window on the screen, and that contains all other view models and all other views. Again, the models are all defined up in the libraries because those are shared between the server and the client. It's just how are things viewed or how are things displayed. It is what needs to be tracked by the client, and I'll show you those windows once we get to the live play. And then likewise, the REversi server itself. This contains the server manager, which inherits from the manager out of the client server library and handles basically matchmaking functionality for a REversi game, guaranteeing that two players connect, that everybody is valid, that they meet all of the criteria needed in order to be able to implement the REversi game. Finally, I have, again, I have the chat server model set up. It is not implemented at this time. Okay, but those are kind of the basics of this. Within the application document, this is where the rule sets for REversi are checked and verified, or what's a legal move, what starts a game, what stops a game, how are things displayed, and the message sending that needs to be sent using that client server library up above. So I hope that kind of gives you kind of a brief overview of what's going on with that particular functionality. Okay, so now if I launch this thing, I'm going to go ahead and I'll start the server and we'll kind of show you what you're going to see here. So this is the basic server. There is a lot of error checking that's still in place. It will show you some of the validations of the moves available for a current player, so forth and so on. But you can see this is just the initial launching, and then kind of some messaging that's happening. A little bit of debug code is still present. It created a server manager with the ID of number one, since that's the first one. And then as I start to create more and more games, it will come up with new servers. And it actually has the ability to be able to spin off multiple server managers if the volume gets too large. Okay, and then now it's sitting there and it's basically spun off its own thread to be able to handle this manager, and now it's going to basically sit there and wait for new connections. So that's what the status of server one. Now, if I had multiple managers, they would all be displayed in this window, and you would see, server 2, server 3, server 1000, whatever the case may be, would all be displayed in this particular window. All right, so that's our server manager. Now, if I go and I launch from my other window here, maybe if I can find it. Oh, where'd it go? Oops. Apologies for that. Pull this over here. Let's go find classes 76 Network REversi. It's about 9 directories deep, but that's about par for the course. Debug. Okay, and so I'll spin this guy off. And so this is what the initial client window will look like. So it's basically set up such that I have that window here. All right, so the initial window that you see, basically it prompts you for a name, and then basically you hit a connect button, and then it connects to the server. So if I type the name, I'll say Bob or something. Disregard the colored squares. This is kind of a placeholder square for what will be the game board displayed as text. And this is kind of an indicator of, once I have multiple windows on the same screen, since I was developing, I got confused on which window I should be clicking in. And so this is a reminder to tell me which window to go to. That's all that is. In a live version of the code, this would not be there. And of course, I wouldn't be running multiple windows on my computer anyway. So if I connect to the server, you can see now that the server has received all of the information. It knows, it's gone through a validation routine to validate what the player that connected. It has assigned a player a connection ID number to it. It has created a game ID because it knows that Bob is looking to join the game. Now the game is not ready to start. It's still sitting there waiting. And so now this client is now in a listening cycle. And so when the client thread was made, it's now sitting there listening or responses coming from the server, such as a game over, a player is disconnected, or those kind of things all are sitting here. So it's currently sitting in a listening state and looking. You'll see some information. It hasn't identified whether Bob is player 1 or player 2 yet. Okay, and so the placeholder information, once the final connection is made, player ID, the default is -1, okay, which has a default name of some bloke. Okay, and then it will also display the last successful move, and then as well as you see the placeholder for when a move can be made. Now, once the window goes live, then you'll actually see the UI of the board, and you can be able to click on that as well. All right, so that's player 1. Now, if I launch another one, bring that over, here's player 2. And so I'm going to kind of resize the windows a little bit so you can kind of see what's going on. Let's say Stella, for lack of a better name, and I hit connect on that. Okay, you can see now if I scroll back, it's actually validating the basic board information. So you can see here now it's found a new client is connected. It says accepted client 2. It has kind of a status update and basically the same thing. It now has 2 players in the queue, and it now knows that I need to update, to basically create the game. And so it knows that the game board, based on the REversi rule set, is 8 rows by 8 rows, as well as the initial placing of the pieces. Okay, and so it's now sending, the server is now sending that game board status to both of the players that are connected to this game. Now, there's a little bit of the debugging or something. It's basically running through, looking for pieces, and figuring out, where there are pieces relative to the square. This is part of the searching algorithm for a valid move that runs on default. And so we'll kind of disregard that. And so currently it's identified valid moves for player 1, which, looking at that isn't entirely correct. The game still works. The initial run isn't quite right. But now that we're set and ready to look at this, I can come in and I can look at this. And so it says that the current player's turn is indicated here. So it's player 1. It shows up on both windows. You can see that the game ID is game 1. This Windows ID is number 4. That was our Stella player. And this is game ID for 2, which is Bob. It took a random roll of the dice and assigned Stella to be player 1. That will be white. And then player 2 is for Bob, which is going to be black. Okay, and you can see right off the bat that, pull this up a little bit so you can see the whole square, that this is obviously our REversi game board. Some of the functionality, if I highlight over a square, you can see that the mouse will highlight over that. Of course, it clears out the number until it receives the board again. But then if I want to make a move, I can simply click that square for player 1, and then it will send that information over to everybody else. So let me move this thing down. So player 1 is Stella, so you're player 1. That's what it says. So Stella's move. Pull this up just a little bit. So she's white. So let's just say we want to put a square down here in 20. You can see that now it's updated the board automatically in both windows as a result of that. And you saw a bunch of text go flying by, all the validation checks and the moves. And so you can see that it's basically, it's checked the square that was clicked, and it knows that to the south there was a piece, so it needs to check if that's a valid move by going and looking at the square that's 2 squares down, and it continues on down that line to validate this. And it finally said, oh, there's a valid move to the south. And it will check all of the directions relative to this piece for valid moves. And if the move is valid, then the game board will get updated with all of the possible moves associated with that. You can see this is the state of the board after that move, and you can see how it's added that 1, which is player 1. That's the same square that you're seeing over on this little part. You can see that the board is updated in both windows, and then it updates the score. It does a tally of how many black pieces versus how many blue. Okay, now you can see that the purple box is shown. This is to keep me from to know that this is not the one I need to be working in. So I'll come up here and we'll do a black square up here. And you can see that, I can sit there and I can click back and forth all the way through. Now let's see if I can run this thing out to a game end kind of scenario fairly quickly. Managed to do it earlier. In fact, I'm going to move this over so I can kind of look here. So we are doing black. So you can see that when I click that, it updates. It does do multiple directions. Let's do a white that's here. And let me just flip through these things. There's a valid black. There we go. It's a little glitchy on the hover aspect of things every once in a while. I'll do this, and we'll do this, and we'll do There's our black, and then I can put a white there. Like I say, the hover functionality is a little touchy. Click through some of these. Apologies for this taking so long. Black on this one. Now I can put white there, put a black there, and then I'll put white there. And I know some of these are very dumb moves. I'm just trying to get it so that I can set up all of this. Put a black there, and we'll put a white there. We'll put a black there, and this. Now we're at a black there. I'm going to work myself out of a, whoops, wrong one. So now we're at white. So grab that one up in the corner. I can get this corner, kind of work our way along as we go. That one, this one, black one there. Now we're back to white. That black there. Usually I can close it out faster than this, so I don't know what's going on, but black, white, black, white, white, black, white, black. May end up filling out the whole box. Apologies for this. White there. And then we do have a black square left. That there. This here. This here. And you can see that now that we've reached the end of the game state, the server has now identified that there are no more moves available for player one, so the game is now over. Okay. Now, obviously, I need to have a window that indicates who the winner was. And fortunately, that's not functional at this time, but that's the state of the game. It does have to, I guess, trust me, right? That's what you want to hear. That if the game runs out of moves early on, it will then terminate the game as well. So that it knows that for some reason I wasn't able to get it to shut itself out. But you can see that it updates the score every move and does everything that's being attached for it. Now, if I go through and I want to connect in, more clients were to connect, they would then be connected into a queue. Okay, the game is still active. It hasn't actually closed out yet. Okay, but if I come down here and I say, okay, here's Ralph, and I connect him to the server, what you can see is that now it is setting up a queue for the next game to be able to work out. So if I come in and plug in Sam, okay, it's now added him to the queue, but it hasn't actually started the game until the messaging is, that is sent to each of the players would be something like, do you wish to connect to the next game? But that's the functionality, and that's a fairly simple addition that would be made to this program with this live application. But anyway, that's kind of the demonstration of what we have happening here. So anyway, I appreciate the effort on this. I hope this meets with your satisfaction for things, and as it goes, if all we need is, I just need a grade to complete the class to get the incomplete lifted, and hopefully this demonstrates my prowess at C# and network gaming communications and server management and those kind of things. I learned a lot from it, and like I say, I was working this at the same time as my senior design, so there is a little bit more overhead behind the scenes. I will provide a link to a GitHub account that has all of this data if you want to bring it down and kind of look through and see what was done. I stuck to a strict MVVM design pattern on this. including appropriate data binding. Okay, all of the graphical information is done through views that are bound into the view models. Okay, and so all the models are set up and handled by the applications, but the views are independent. So the idea being that the back end code could be deployed onto any other system as long as you were to be able to create the views that tie to the view models, in whether it's a mobile setting or a Linux setting or anything like that that allows you to program in C#. So anyway, that's my idea and my term. I learned a lot just in general from this class in terms of functionality in C#. As always, my projects get a little carried away. I tend to do more than I probably should. And then, of course, in this case, I didn't even get all of the simple requirements, but some of the advanced features are present in this. So I'm hoping that will offset some of the main requirements. Hope this meets with your approval. And so with that, I will stop the recording. Thanks again for all your help on this. I will talk to you later. Thanks, Mark, for Dr. Randall. Bye.